Hi, this question is about the non ideal spring, and which is for the AP Physics C mechanics students. We will try to find out the force applied on this bumper when we will compress it up to the some distance x as given us in the question. So, right now, the bumper's position is x is equal to 0, which can be regarded as an equilibrium position. By the way, whenever we say an ideal spring, so an ideal spring executes the simple harmonic motion in which you know that acceleration is directly proportional to the displacement and always directed towards equilibrium position. So if it is non-ideal spring, it means that it is not necessary that its acceleration will be always towards equilibrium. Okay, and it might not be executing the simple harmonic motion. I will show you this thing in the last minute of the video. So let's say we have now compressed the bumper to the new position x. So this distance is x. So now how much energy is stored in this spring, non-ideal spring? It is given as a function of x, and that is equals to 3x cubed minus 4x squared plus 2x. This equation tells us that how its elastic potential energy is changing with respect to x. So, anyways, we have to find out the spring force right now exerted as a function of x. Now, since it's a non-ideal spring and we know the relation between the force and the elastic potential energy, which is we know that it's a negative of derivative of potential energy with respect to x. So we will just take its derivative. So derivative of the potential energy with respect to x is, so when you will open the bracket, so we can apply it this derivative on every term. So we can write it like this. So this negative and negative will become positive. So 4 is a constant, it will come outside. So negative 3. And when you will take derivative of x cube, and you can apply this power rule which says that the power is multiplied with a coefficient, so 3 times 3 here, and x cube will be written as 3 minus 1, so x square, right, plus 4 multiplied by 2. I'm applying the power rule now on this thing, so this 2 will be multiplied with 4, and this can be written as just simple x raised power 2 minus 1, and minus 2 derivative of x is just 1. So it is simplified negative 9x squared plus 8x minus 2. So this is finally the spring force with respect to x. So that should be the option B. Now I quickly explain you what is the meaning of this force. So if you put any value of x, any value of x in this expression, right, you wouldn't get the spring force greater than 0. It is always less than 0. It means that all the time the spring force is directed towards leftward. Conceptually, this spring force is not exerted to the right all the time, it will be towards left. So option B is the right answer.